So this is going to be a demonstration of thermal conductivity. What I have here are two very similar looking blocks. One of them is made of aluminum and one of them is made from a rigid foam. When we touch the blocks, and you might have noticed this around your own house, they might feel different. This block feels relatively warm, and the metal block feels very cool to my touch. And you can think about things around your own house where if you touch something that's made of metal, a lot of times it feels cooler than the other materials around it. But the thing is, it's not actually cooler. These are going to be at the same temperature, which is the same as whatever temperature our room is at right now, probably about 72 degrees Fahrenheit. When I touch them, I'm not actually feeling the temperature of the block. Instead, I'm feeling what happens to my hand. In this case, when I touch the plastic foam block, basically nothing's happening. This is an insulator, which means it's not good at moving heat in or out of things. Whereas the aluminum is a conductor. It moves heat in and out of things very easily. So when I touch the aluminum block, it feels cold because the heat is moving out of my hand into the block. So I can feel my hand cooling down much faster when I touch the aluminum block versus the foam block. But I've got these two rings, and I'm going to put ice cubes on there. The rings are just to help make sure that the ice cube doesn't slide off of the block. And I will grab two similarly sized ice cubes, approximately the same size. Let's put them on the blocks and see what happens. The aluminum block is melting very quickly. The foam block is just kind of sitting there. Once again, when I touched these, this one felt colder to the touch than this one. But it doesn't have to do with the actual temperature. It has to do with the thermal conductivity of these materials. An insulator is not thermally conductive. So even though it's warmer than the ice cube, it is bad at moving heat into the ice cube. It's bad at conducting heat into our ice cube. Whereas the metal is a conductor, it is very good at moving the heat, conducting the heat into the ice cube. So even though it felt cold to the touch, it's moving the heat from the block into the ice cube and melting the ice much faster than an insulator because it moves that heat very quickly with its high thermal conductivity. So once again, when we felt these blocks, this block felt kind of just room temperature, kind of normal. Some people would even say warm, but this one felt very cool to the touch. That's because this one, even though it's the same temperature, is pulling heat out of my body faster, the same way that it put heat into the ice cube faster than our insulator block.